Welcome back. We're going to take a look today at exercise 4 using SolidWorks 2020. So in this exercise, as you can see in front of you, there's actually a rendering of what we're going to work on. That's the exercise. It's just a hand wheel, and it's going to have some features in it, like, for example, the sweep feature we're going to take a look at today, and the spline tool and the sketch tools. And so those are more for free form design. As you see, it looks kind of like a sculpted shape to some extent. So we're just going to scrape the surface of that today. We're going to review Revolve features a couple times in here, but we're going to take a look also for the first time at the hole wizard. And the hole wizard is really nice because it has a whole bunch of different types of holes to select from that are standard. For example, counterbores, countersinks, national pipe threads, and things like that. So we'll go ahead and we'll get started. First of all, make sure that you go to the Vertanu 1 webpage, and that's just under V as in Victor, E, R, T, A, and N as in Nancy, U, X. Make sure you put the 1 in there, .com. And it should bring you to the web page. And from here, instructional manual, SolidWorks basics. And if you want, you could download it if you haven't downloaded it already. Otherwise, it should be in your download directory if you've been following along every week, so you don't have to keep downloading it. It'll just keep making copies. I actually have it already downloaded. And this lesson starts on page 44. Okay, so let's begin. So we're going to sketch out this profile that you see right here, 3 inches in height, really 1 inch thick to start off with because it's going to be a revolve feature, and then we're going to have a little hump in there for it's going to be a 1/2 inch radius, and then we're going to learn how to do a sketch chamfer, 1/4 inch at 45 degrees. So let's begin. I'm going to go to New Part and hit OK. Select the front plane and start a sketch. Take your corner rectangle tool and hover over the origin. And when you get the orange dot, click, drag it to the upper left. So X will be about 1 and the Y is about 3. Once you got that, go to Smart Dimension, click on this line over here on the right. Click to the right of it when you center the dimension and type in 3. Click on the bottom line and make that 1. Now we're going to go ahead and take a look at the sketched fillet. But before I do that, I'm going to zoom in so you can see this better. I just hit the F key on the keyboard for zoom to fit. All right, now you'll see sketched fillet is right here. There's also a little arrow to the right of it, which you'll find sketch chamfer. Now, chamfer, remember, is an angle, so click on sketch chamfer. We're going to go, in this case, it's going to be the same either way. We could go distance to distance or angle to distance, but it's going to be a 1/4 inch. And because it's at 90 degrees, once we put 1/4 inch equal distances, it's going to come out to 45 degrees. So whichever one you prefer, you could go angle to distance, type in 45 degrees and 0.25, or distance to distance, equal distance, 0.25. Once you have that in there, go ahead and click on this upper left corner. A lot of people who've come from older CAD systems have a tendency to click on both intersecting lines. You could do that. That's one of those instances, though, where if you're taking a test for this in front of a potential employer, they see you doing that. It's kind of old school. It's best to click on the upper corner because, remember, everything's about efficiency. That might seem like that's being a little nitpicky, but the fact is that those are things that an employer might look for as far as your knowledge of this software. Okay, now what we're going to do is we're going to go ahead and draw in a circle. So go to the circle tool and hover right about here and get an inference to the 0.25 edge there of that chamfer. And just somewhere in the middle where my pointer is somewhere similar to that, click. And I'll drag out a circle, and the radius should be about 0.5-ish. Now go to Smart Dimension. Dimension the diameter of the circle. Make it 1 inch, because remember, it's a diameter now. Radius is half of a diameter. And now click on the center point of that circle to the bottom edge and click over here on the left to drop that. And I'm going to need to use my cheat sheet. It's 1.75. All right, you'll see it's still blue. That's because it could float left and right. So hit escape a couple times on your keyboard. We're going to assign a relationship that will align it vertically, the center of that vertically to the 0.25 edge of the chamfer. So here's how. First, select the little blue cross there at the center point of the circle. Now, after you select that, release. Now hold Control, because any subsequent selections, you have to hold Control, and otherwise it won't stay. So go ahead and click on this vertex here. Vertex is the end of a line. You'll see it highlight in orange. Click. Release Control. Now take a look over on the left and you'll see add relation to vertical. Now watch as the circle is blue right now, which blue is an indicator of underdefined geometry. Watch it change color. It should turn black. Doesn't look like it moved at all because it was actually in alignment. It just wasn't tied down. We basically tied it down. Also, another piece of advice for my new users out there, especially those of you taking my class, avoid, when you go to relations here, avoid this one. It looks like a boat anchor. It's fixed. It is good for some advanced purposes, like if you're importing geometry from somewhere, a DXF or DWG file, for example, and you want to lock something down the way it was. That's a good method. There's other tricks out there too, but for my users, my students, please don't ever use that in my class. We might touch upon it in the advanced class, but for the most part, if you add that, you're going to have so much frustration, especially those of you who are taking this online, because it locks down that geometry, and a lot of times students can't figure out how to unlock it. So just be aware of that. You don't want to anchor things usually. Hit the green check. All right, we're fully defined. Now last week, we took a look, and especially in the lab, I think we looked at trimming. And normally in the book, I talk about trimming here, but we actually covered it last week. So I want to show you now some other functionality here. Now, this functionality has been in SolidWorks for 20 years, but if as long as I've been using it, when I first started using it, it wasn't there. So it's really kind of a neat thing. And I wouldn't say it's 20 years. It might be less than that. But anyhow, we're going to leave these contours in here, and I want to show you how you could use those contours without trimming them and still get a Revolve feature. Here's how. Go to the Features tab. Go to Revolve Boss Base. Now, you won't see a preview because notice we didn't put in a centerline. Normally we use a centerline. We learned that from exercise 2 weeks ago. And because that's the revolve or spin center. But we don't really need it. That centerline is really is only there if you have like geometry that's offset from it, and it's going to create a void or a hole in the center once it's spins around. There's no hole in the center right here just yet, so we're not worried about it. So here's what we could do for the axis of revolution. You could go ahead and select, actually, we'll select that later. Let's first take a look at selected contours. Click on the selected contours. Now this enables you to click on multiple contours like this one here, this one, and then that one, because those are all three that we want. If you miss selecting one of those, you might have a gap or an opening somewhere, so just be aware. Now click back on axis of revolution and select this right edge that we want to spin around, and you'll see it wraps around. So selected contours, I had discussions with users about this, and some of us like it, some of us don't. I still want to show it to you. It can be advantageous. I used to be on the side of that kind of sloppy geometry that's left over. I like to trim my things out, and there might be users out there that feel the same way. So just be aware, wherever you work, it might not be acceptable to do selected contours. So it's up to you. The real thing I used to like to teach most of all was just to trim everything, make sure it's one contour. But that functionality is there if you want to use it, and if you're the boss, then there's no question. Hit the green check. All right, click over off of that. Now we're going to go ahead and add a sweep that's going to look kind of like an elephant trunk. So select the front plane, start a sketch. And this is for the spoke, by the way, that we're going to make. And then we'll pattern it. So front plane, start a sketch. And Control 8 will bring us to that front view orientation. Remember, you could hit the spacebar too if you want and hit the front view orientation. However you want to do it, there's a dozen ways. And now let's go to the Centerline tool. Now, off of the origin at the bottom middle of this hub, drag it straight up and get it to where the colors break here for the gray, where you see the underside versus the top side. So right about there. It doesn't really snap to a true center. We're just eyeballing it right now, but we're going to add a dimension. So go to Smart Dimension and drag that to the right here just to get out of the way and put in 1.75. Now I know you're thinking, well, we put that one in there earlier to specify where that circle was. Unfortunately, I don't know of a way to use it. If someone else knows of a way to use that and snap to it, by all means, other than going to a quadrant on the outside, which that's obvious. But we need this, what we're going to do to make the spoke actually on the inside. All right, so we have that geometry. Now, take a look up here. Find Spline and hit the little arrow to the right of it. You'll see Spline, you'll see Style Spline, and Equation-Driven Curve. These three items, there's different uses. Like, for example, an equation-driven curve, I've seen where that's been used for gear teeth and things like that. And so it is a useful tool. We're not going to use it ever in this class. But the next one is Style Spline. Now, Style Spline, when you're designing something free-form, like if you're drawing a sleek body of a car, and that's a very nice tool. That's going to give you nice, elegant shapes, and it gives you control points that you can actually grab pretty easily and adjust. Then there's just Spline. Now, these splines are actually non-uniform rational B-splines, initially based off of polynomial splines, which those of you remember math back in college math, you might have talked about polynomials. But anyhow, the NURB is a non-uniform rational B-spline, and we're going to go ahead and use those to make a sleek contour for our spoke. Now in the book, I don't use a spline. I actually have analytical geometry, which is lines and arcs. But I thought it necessary to start showing this early because things are just more ergonomic these days, it seems, lately. So anyhow, not really, but still, it's good to know. We're going to go with the easier of the two to use. Style Spline will use a later exercise, but the regular spline, the good old spline tool that's been there since SolidWorks has been around, we're going to use that because it's pretty easy to use, although it doesn't, to shape it, not as nice as the Style Spline. Okay, go ahead and get to this vertex over here of that center line you just drew. When you get the orange dot, click, drag it, and let's snap it to this quadrant on that hub. Click. Now drag it out, and you could use the parameters box on the left just to get close. I don't want you to type anything in there, but like drag it out maybe, like see it says minus 1.669 or something like that. Around about there, 1.7, 1.8 is fine. Click, and notice I'm horizontal. Now drag it up, and look at how the contour starts adjusting. Again, non-uniform rational B-splines are controlled curves that essentially mathematical behind them, the mathematics behind them is actually controlling that slope that you see there, and the weight as they call it. All right, anyhow, let's go ahead and drag this up, maybe about 2.5 on both of those. Click, drag it over here to the left, about minus 3-ish, and by 2.7, somewhere around there. Click, and one more to level it off. Now, if it's starting to fall off the screen, you could hit the F key, and then it will give you a little bit more space. All right, and then flatten this out a little bit, just like I have here at minus 3.5-ish by 2.7-ish. So click. Now hit escape. All right, so you can see our curve. You can grab these control points. Now here's the thing. When you grab those points, or the nodes, some people refer to them that, you could stretch things out. Now when you do that, be aware, little arrows appear. I don't want you to touch those today. Stay away from those little arrows. Those apply weight and could actually put too sharp of a bend in your curve, and it might error out what we're about to do. So you want to just use the standard defaults that they have in there. So don't tinker with those little arrows. But they are nice to add weight to the curve. Now, let's go ahead and hit rebuild up at the top. Now, the rebuild button, we talked about this, I think, day one, actually. It's not quite to this extent. We'll go into it right now a little bit. Rebuild essentially will exit you out of the sketch that you're working. Won't delete it. It just leaves it there. It grays it out. And if you think of the sketches that you're making, they're kind of like layers on top of each other, each new sketch. You could go in and you could edit those sketches or not, or it could start new ones. But anyhow, that's going to get us out of the sketch. So hit rebuild. The green looks like a traffic signal up there. All right, now, one last thing. Sometimes you'll find yourself in a challenging state with SolidWorks where you're just getting frustrated and you just want to kind of exit out or restart, but not with restarting SolidWorks. Try hitting rebuild. Sometimes it will kick you out of whatever you're in and you could continue on with your task. So just that's a little piece of advice as well. All right, now we want to make a plane. A new way to make a plane. Last week we touched upon offsetting a plane. Today we're going to take a look at making a plane perpendicular to this curve so we could draw a profile and sweep it along. So to do that, let's go ahead and rotate this a little bit so you can see it. I'm holding down the middle wheel and dragging down to the lower right a little bit. Okay, let's go, and I want you to find reference geometry up here and find plane. Now you'll see there's first reference, second reference, third reference. Now what we're going to do, we're going to let it fill in for this as we just click. What's required? Now, by the way, this is probably the most advantageous way to make a plane. I mean, there's several ways to make a plane inside SolidWorks, and we're going to explore them. This is one of my favorites because you can make a plane at any angle just by drawing a sketch on another plane and then making new planes off of that. Now here's what you need. We need to select the vertex where the plane is going to contact. So select this point. That's the first thing. Notice it went to second reference now. It's blue. It's looking for input. Go ahead and select the curve now. And there it is. You should get a plane perpendicular to the curve. Go ahead and hit the green check mark. Now, click on the edge of that plane and start a sketch with the quick launch. And I'm going to keep it in this isometric view. You could go normal too. Remember, Control 8 will do that. But what I'm going to do here is I'm going to go ahead and select the circle tool and find that endpoint. Now, if you're unable to snap to that point, you might have to rotate or go normal to. Go ahead, and once you have this and you see both and you see the origin, get that orange dot, click and drag out a circle about 0.2 to 3. And then go to Smart Dimension and dimension the outside to a 1/2 inch. Actually, let's make it 0.75. Make it a little bit bigger. I know the book says a 1/2 inch. We do more of a tombstone shape, but we're going to make this a little bit different. Okay, so we're at about 0.75. Now, if some of you have very dramatic curves, be where this might fail, especially at that large of a size. Let's, just to be on the safe side, because I can't see what everyone's doing on their screen, double click on that 0.75. Let's change it back to 0.5. If this doesn't work, you could always go back and edit this circle just by double clicking on it and change that to even 0.2, or flatten your curve out more. Your curve might be too jagged and then it intersects when it sweeps along. So that could be a problem. Okay, now let's go to Features, the tab, go to Swept Boss Space. All right, the first thing it's looking for is the profile. Go ahead and select the circle. That's our profile. And it automatically went to the path input. So the path is now blue here. Select the curve. And you should see it make its way into the actual model. Go ahead and hit the green check. Now remember, if it's failing, like you're not seeing a preview and you have input in both of those, it might be that 1/2 inch diameter is too big. Try change it to 1/4 inch to 0.25 if you have an issue, and then rerun the sweep. Go ahead and hit the green check. All right, now let's hide that plane. You could click on the edge of the plane, and remember there's the hide button, the little eyeball. We're going to learn how to pattern now. Actually, we've learned how to pattern a couple weeks ago when we patterned the ribs with exercise 2. So this is a bit of a review. Select the sweep from the model tree or feature tree right here, and because that's what we want to pattern around. Go to the little arrow underneath linear pattern. And look at all these different types of patterns. There's linear pattern, circular, there's mirror, curve-driven pattern, sketch-driven, table-driven, fill pattern, and variable pattern. So just know there's a lot of patterns, methods. Go to circular pattern, and make sure it sets equal spacing, 360 degrees. Let's bump that up to 5 for 5 instances, and it's always inclusive of the original. So 5, it's going to be the total. Now select the outside surface of the hub. Don't select the donut shape up here. This one usually doesn't work. Other CAD systems actually it works in. This CAD system it doesn't, but go ahead and select this surface instead. It'll work on the chamfered surface, or it'll work on just the straight cylinder. Once you have that, you'll see a preview. Go ahead and hit the green check. And now we have our spokes. Now let's go to the front plane in the feature tree and start a sketch. Hit your spacebar and go to front view orientation. Go to the circle tool and locate the midpoint of the spoke on the left-hand side here. When you get to the midpoint, drag out a circle. Smart dimension it at 1 inch. And now we're going to need to put in a centerline. Now there is actually a centerline in there already from when we did our cylinder. Any cylindrical object actually has what they call a temporary axis. You could go to view and hide show, and you'll see temporary axes, and you can select it. But then it's annoying because there's a lot of them in there sometimes, and it could clutter your screen. So I don't show that much anymore, but we might see it in the future exercises. But go to centerline, and at that origin, click and drag up a vertical centerline. And now go to features and revolve boss base and hit the green check. All right, so now we have our hand wheel. What we're going to do next is we're going to go ahead and add fillets. So go to the fillet tool and make sure your fillet's set to 0.2. And here's one of SolidWorks' really neat strengths. Most CAD systems can't do what we're about to do here. Go ahead and select the whole hand wheel, and it will fillet all of the intersecting spokes automatically. Most you'd have to go in and click on every edge there. Go ahead and do it on the hub as well. And you can select this surface here, the chamfer surface, and we've just added fillets just about everywhere. So surface on surface on surface. Normally you could select edges too, of course, but I just wanted to show you. All right, let's rotate this around to the bottom side. So you're looking at that opening there. Now what we're going to do is we're going to put in a counter bore right here. Go ahead and select that surface. We're going to center it too. And then you'll find the hole wizard. Now if you hit the little arrow under hole wizard, notice there's hole wizard, there's advanced holes, and there's threads. Thread tool is really nice. I don't have a video yet on it, but I would recommend seeing it. I do threads in my videos still kind of the old way, the original way. But this thread tool is great for standard threads, very quick and very easy, and I hope to make a video soon for it. But I'm sure there's tons of videos out there on YouTube for those. Okay, but we're going to use the hole wizard today. Now you'll see there's a whole library right here. There's counter bore, counter sink, standard drill hole. Here's straight tap, tapered tap, which are national pipe thread would be included in that. You've got legacy holes, so you can have specialized holes and make your own little library there of those. And then you see counter bore slot and counter sink slot, and finally slot. We're going to keep it on counterbore. Now, you'll see the standards. Just keep it on ANSI inch. And the type, if you click on this, you'll see that there's a bunch of different fasteners. Now, don't misunderstand that this is going to actually put the fastener in. It won't put it in here automatically. But if you have the professional version of SolidWorks, or that includes Toolbox, Toolbox is kind of like a library of nuts and bolts and things. And it will automatically put it inside the context of an assembly. So just be aware. But if you add these and later on you select the edge, you could have it automatically put those in, again with Toolbox, which we'll take a look at in the advanced class. All right, now, so we're going to stick with binding head screw. On the hole specifications, it probably says 00 if you've never used it before. So scroll all the way to the bottom, go with a 3/8 inch. And notice the fit. You have close, normal, or loose. Go ahead and let's go with close. And scroll down here a bit further. The end condition, instead of through all, make sure it's set to blind. We're going to have it drill down 1.5 inches deep, so put in 1.5. And then these are some other settings you could tinker with if you like. We're not going to touch those, but let's now go to positions. The tab up here, go to positions. Move your pointer onto that surface, and you'll see you could position one anywhere you want on that surface. You could, don't do this yet, but you could click in multiple areas, adding a whole bunch of holes in different locations, and then you could position them with dimensions. But this one, we're going to position it right on the origin, which is dead center. So go ahead and click, and then look at that. You could hit the right mouse button, because it has a little green check mark there, to apply it, or you could hit the green check mark in the upper right, and then click off of it, and there it is. Now that actually does have an annotation that follows it. So when you go into a drawing, you can actually call it that annotation pretty easily. One other thing, let's go over to materials, right click on materials, go to edit material, and let's go with chrome stainless steel. And remember, we usually go with megapascals here, or MPa. And we can see yield strength is 172, tensile strength is 413. Hit apply and close, and it adopts the properties of that material. And that's about it for that exercise. Make sure you save that. And what we're going to do next is we're going to take a look at the lab. Now, lab 4 is a challenge. It's a very good challenge. This is what you might see out in industry. Most of the parts I've given you are pretty generic thus far. They're not particularly difficult to model. This one has some significant dimensions that you have to follow. So those of you who aren't fluent with reading a print, this will help you learn to read a print. And mind you, these prints are not very good. My background was mostly modeling. I did prints as well. I used to actually draw on the board back in the 80s. And so my drawings, I do a lot of the auto dimensioning and things like that. So they're not always the greatest, but everything is here that you need on this particular drawing. So you could find it. May not be the best drawing, I'll admit to that. One of these days, maybe I'll update it and fix it. All right, so what we're going to do is we need to make this enclosure. And you can see the bottom arc is 0.75. Now, again, you might say this looks awfully familiar. It's using the same technique we learned with exercise 3 and later lab 3. Lab 4 incorporates that same shape that the head had, but it adds some additional angles to it that you see. There are 115-degree angles, and then a big, as I called it, the Alienware type head. So anyhow, what we're going to do, we'll start that off. So we have 0.75 for the bottom arc, the top arc. And oh, by the way, if you wanted to, you could download this. Usually up here, there's download. And then you could go over here to rotate. And I'm going to go ahead and rotate counterclockwise so it's easier to see. All right, so from here, we're going to go ahead. Let's see what this radius on the top here is 1.5 inches. We have a 23-degree angle on these sides and then 115 degrees. So let's give that one a shot. go to New, Part, and hit OK. It's symmetric, so we can select the front plane, start a sketch, and use a center line to start you off. And make it about 2.5 inches in height. And then change that center line to just the object line, just line as they call it. On the left here, click and drag one up about 1.5 inches or so, and then another one, maybe about 1 inch, at a steeper angle. Click. And then hit escape. Now you could drag from right to left to capture everything, and then hit mirror entities. Go to tangent arc and put the tangent arc in at the bottom. The top is not tangent, so try something else. In this case, go with 3-point arc. Click here and connect here, and then have that bow out like so, and then hit escape. Let's put the dimensions in. Smart dimension, the bottom arc, it's going to be 0.75. Now, sometimes I've seen students who drew it in such a large scale that when they put this dimension in, it gets an error. What you might want to do, this is one of the times you might want to actually use the do not click on thing that I talk about. So like if I click on this arc, I hit escape, by the way. I click on this arc and you'll see the dimensions here. Sometimes you could plug in closer dimensions to squeeze down or scale them all. It tries to auto scale, but sometimes the algorithm, I think, has some difficulty depending upon the geometric conditions that are on the sketch that you're drawing. So just note that sometimes you could change it here, or you could actually just click on the lines and squeeze them down yourself and then try adding the dimension later. It happens every once in a while and it can be frustrating, but just be patient and keep trying. All right, smart dimension, the top arc now, that's 1.5. And then this angle here is going to be 24. And then this angle here is 118. And then the distance between the two, let's find that drawing. Let's see here. And we have, let's see if I can zoom up a little bit. All right, we have 1.25 from the center there to the center at the bottom. So let's put that in. So from center to center. Now this center might be difficult to see because there's a center line on top of it. Look for the horizontal little blue cross there. Click and then drag this out. And 1.25. All right. Now hit escape and we grab that center at the bottom, drag it down. Oh, you know what? We're not done yet. Still missing a dimension. Okay, let's see what am I missing here? Let's see, 1.5, 1.25. Ah, here we go, the angle. 1 inch from that corner to the center point. So don't forget that one. So this corner right here to the center point should be 1 inch. Now it should be locked down. So when we after we hit escape, grab that center, drag it up and let it snap in, and now it's fully defined. You can lay these dimensions out to something that you could read a little bit better. So if you need to change it, you or someone else needs to ever change it, they're readily stacked and available and easy to read. Let's go to Features, Extrude Boss, and let's look at our drawing. We can see here it's a 1/2 inch thick, and the draft is 25 degrees typical. So let's go ahead and type in 0.5 here, and then draft. I just want to verify that. Let's see, 25. Okay, this one. All right, hit the green check. Now, this one we can, because it's broken, we can put the big fillet on first, unlike our lab last week. And that fillet, or that radius right here, it's a 1/2 inch. And then there's a chamfer of 30 degrees by 181. So we'll put that one in. So right here, it should be a 1/2 inch. Apply. And I go to chamfer, underneath fillet. And it's going to be 0.181 by 30. Select this edge here, and there it is. Hit the green check. Okay, now we're going to shell it out. Rotate this around the backside, go to shell, and let's find where that shell is. And the typical wall is 60,000, so 0.06. Select this face, and then hit the green check, and it should shell it out. Now, if you hit the green check without selecting a face, it's shelled. It's just that you didn't select the face to be opened. So if that has happened, you can't reshell it. So you have to actually edit the shell. You have to right-click on the shell, edit the feature, and then select the face. Another thing you could do, you could just hit undo, get rid of it, add another one, or you could delete the shell by selecting it and hit delete on your keyboard if you've run into some issues where it's not working, because I've seen it quite a lot over the years where students shell it, but they don't remove that back face. So they have difficulty with that. Okay, let's put in that pattern of those openings. Select this face here, start a sketch, and let's go normal 2, or front is fine. Let's go with the center line, and I want to put it on the center here. Go to the regular line tool, and right about here, click and drag out a little angle. We get to use that same technique that we learned in the last exercise for making the head of the ratchet here. So we got that line, hit escape, and then click and drag a fence around them both from right to left, and it selects them easily. Otherwise, you have to envelop everything. And now we can just go ahead and hit mirror entities. And let's go to tangent arc. And you just need a tangent arc on the top and on the bottom. Once you have that, let's take a look at the drawing again. And we need to have a radius at the top of 0.2 and radius at the bottom of 0.1, and they're spaced 0.5. And then there's this bolt circle here that they're aligned to. And let's see, where's that dimension there? Oh, here it is, 0.7. So 0.2, 0.1, 0.5, 0.7. Let's do the bottom, the smallest one first. 0.1, 0.2, center point to center point, 0.5, and from this point to this point, 0.7. All right. Now we could use the sketch to actually make a pattern. Let's give that a go. We'll do a sketch, a circular sketch pattern. So over here, first select the geometry you want to pattern. So in this case, you can select this surface in here. It's like a light grayish surface. It will select the geometry. And now you could go to circular sketch pattern. Now, you want the center to be located over here. So you could grab that center and just locate it right there. These, I believe, are 24 degrees off each other. Maybe not that. Oh, yeah. Put in 2. There we go. And put in a select dimension angular spacing. Put in 3. Now, I'm going to show you just this one side, adding these, and we're going to cut them, and then we're going to mirror them over to the other side. There are several ways you could do this. I'm showing you 2 ways, giving you 2 methods, basically, in this case, just so you can see how they're done. Actually, yeah, we'll actually just mirror these over. So hit the green check. Oh, and make sure you dimension radius. Hit the green. Okay. Now what we're going to do, I guess we can mirror those over, I suppose, but Instead, let's just make sure let's just go to Features, Extruded Cut, and you want Through All. All right, now select the Cut Extrude and hold Control, and you'll find there's a right plane in the middle. Select the right plane, and then go to Mirror, and you should see it mirroring to the other side. So now you've just seen two techniques. You've seen a circular pattern, I should say circular sketch pattern, and also we've seen actual mirroring here. Okay. The next thing we're going to work on is there's a boss in the center here. So I'm going to select this face, start a sketch. I'm going to go and highlight the edge here, which highlights the center point. Drag off a circle about 0.3 or something like that. And let's take a look at the drawing here. That indicates it's 0.835. So let's go to Smart Dimension, 0.835. And the extrusion depth of that is right here. It's kind of hard to read, 0.3. So go to Features, Extrude, 0.3. I should say extrusion height, 0.03. My apologies, 0.03. Not nearly that big. All right. Now there's these little details that you'll see in here, these little cutouts. And again, because I don't want to make a huge drawing here, everything I put on something that could be printed out on an A size sheet, which is 8.5 by 11. You'll see the dimensions are really squished together. That's why I said these are not the best drawings. But we can see over here on this backside view, we're 1 inch in height. I'm sorry, not 1 inch, 0.1, and then 0.05 wide. So that's the rectangle that's centered. And then it's located, let's see here, 0.371 from center. So let's put that in. And what we could use for this one, select that face, start a sketch, hit your spacebar, and go to front. Go to the, let's first draw a center line. Find the center, drag it up. Now go ahead and find, we're going to use the center rectangle tool here. Center rectangle. And somewhere on here on this edge, click and drag out a rectangle. And let's dimension that. This is going to be 0.5. I'm sorry, not 0.5, 0.05. And this is going to be 0.1. So I'll change that. All right, and then it's located from the center. So click on this bottom edge to that point, and that is going to be a dimension of 0.371. All right, now we could go ahead and cut that. Go to Features, Extrude Cut, Through All. We also have a fillet feature that's in there. And the fillet, you can see right here, it's a radius of 0.1. So let's go to the Fillet tool, make sure it's at the 0.1, and select this edge right here. Hit the green check. Now that we have that geometry, we could go ahead and we could put our fillet of 0.03 around this entire edge because we needed those edges so that we could align things. So I'm putting in later. So right there. I guess we didn't really need the edges. We could have probably gotten by without it. Okay, so now that we have that, we need to pattern it. And if we're looking at that, you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 instances, 360 degrees around. So we could select that fillet and the cut extrude, go to circular pattern. For the pattern axis, just select like this face here, and increase that to 15. Hit the green check. Okay, and now here you'll sometimes get this, unable to create a pattern. Decrease the number. Sometimes this happens. Try geometry pattern. And again, we get a little error message. So we need to do a couple different things here. We might have to put the fillet in later, or maybe this outside fillet in later. There's a couple different variations of what we might need to do. And let's see, let's turn that off. Cut, extrude, and fillet. Let's delete that fillet in there. Maybe I had the wrong, oh, you know what? I had the wrong fillet. There we go. I had the wrong fillet selected. So you might, to correct that, just cancel out. Let's start over again with that one. All right, I accidentally selected fillet 3, which fillet 3 is that 30 thousandths fillet that travels all the way around. Doesn't want to pattern that, that's fine. So let's go back to circular pattern and select this little box up here for the directions. Select that outer surface here. And we're going to, then the features, the pattern. You could actually select this sidewall and then this fillet. Now increase it to 15. You could type in the value if you like. Hit the green check. And there we go. All right, so my mistake. Now let's select this face. And the rest of this little logo, I just had fun with it. You don't have to put it in if you don't want to. I don't have any dimensions for it, just eyeball it. And I'm going to go to Extrude Cut. And I'm just going to have it go 0.02 deep. There we go. It's just a fun little, it's like the moon in front of the Earth. Okay. Now let's go on the back side. Top's done. Select this face, start a sketch. You can click on normal 2 for that. And let's look at our drawing. On the inside here, we have some bosses. You can see here there's 0.175 diameter, 3 places, 1, 2, 3. And the height here is given over here, the 0.375 for the height off of the floor of the shell. And there appears to be a taper, and there's also a cut of the hole, 100 thousandths by 100 thousandths. So 100 thousandths diameter, 100 thousandths deep in there as well. So let's first get these in. And I believe there's draft on here. I don't know if I specified that, so you don't really need to put it in unless it's specified, but we'll put it in just to show you because it might be on this print. Usually you want draft on a plastic part, otherwise it doesn't pull from a mold very well. Okay, I'm going to go to the circle tool. Now this one's really easy right here. Just draw that there, and then draw one right about there. Let's go to the Centerline tool. Okay, I actually added 2 center lines there. Sloppy sketches. Let me delete one. Okay. And we'll mirror this across. I'm going to click, hold Control. I hit Escape. So make sure you hit Escape. Click, holding Control that center line and that line. And let's go to Mirror Entities. And now we can position them. The bottom one doesn't need to be positioned. Oh, one thing. Let's make them all equal too. So I hit Escape. Control Select one of the circles on the side and then the one at the very bottom and make it equal. Because the 2 are symmetric, because they were mirrored, we don't have to select all 3. You could if you wanted to, but you don't have to. All right, and we'll put in that 1.75 diameter for one of them. Or I'm sorry, 0.175. I need more coffee today. All right, it rounded it to 0.18, that's okay. Now we need to position. So let's look at where that's located. So we can see it's 0.125 offset from the center here, and then 0.75 from the center. So from here let's select the outside of this edge here and then get it over here to the right, and it's going to smart dimension. Make sure you get the vertical smart dimension. Click, and it's going to be 0.125. And now click on the center point to the center line, and that'll be 0.75. All right. Now, just to show you, if you missed what I did there, I actually selected the outer edge, and that selected the center of that, which is what we wanted to get. Now I'm going to go ahead and go to Extrude, and this gets extruded 0.375. And let's go ahead and add a degree of draft. Hit the green check. Now go ahead and select one of those faces, start a sketch, and there's, you could just draw these in. If you want to mirror them, you could too. But like, let's see here. That's 1, 2, 3. Hit escape. Click and drag a fence to surround all 3 and make them equal on the left. And now add a dimension to one of them, 0.1. Features, extrude cut. And we're going to have it cut down 0.1. And let's add a degree of draft on that too. Hit the green check. And so now we actually have the little holes that are in there for snapping together to the mating part. Now we need to put in, there's a little boss there for something. So let's go to sketch on the surface, hit the spacebar, go normal 2, draw from the center there. Now remember, you can wake up that center by highlighting this edge. You don't even have to click. Drag out a circle and then another circle. And let's take a look on the drawing. One's 0.5. The ID is 0.5. The OD is 0.6. Now go to Features, Extrude Boss, and let's look at what that's set to for the depth. Over here, we could see if we follow the little tracer line, extension line, we're looking at 0.13 for the height. Hit the green check, and we're done. Now, there are ribs you could put in there if you like. You don't have to in this case. Just for this lesson, we've done an awful lot. This one is a very challenging one to work on. It's a good one, definitely for a portfolio piece. There's a lot of things that you had to do to add to enhance this. All right, that's it. And that concludes exercise 4.